Hello, this video is about finding the absolute maximum and absolute minimum values of a given function f of x. So what is the absolute maximum? Is the highest point that you can have on a given curve. The minimum is the lowest point on a curve. So that's the smallest point on the curve is the absolute minimum. Now this video is about finding the absolute maximum value and absolute minimum value. So to find those absolute maximum and absolute minimum values of a given function f of x, the first step is to basically find the critical points of the given function. We already discussed the critical points. That is, to get the critical point, you have to take the derivative of the function, set the derivative equals 0, and then solve for x. So the solutions of f prime of x equals 0 are what we call the critical points. After you're done with the critical points, you're then going to evaluate the function at those critical numbers. Okay, so that's step 2. Step 3, you're going to evaluate the end point of the interval at the critical. You're going to evaluate the function at the end point of the interval that is given to you. And then step 4, you're going to compare numbers that you got from step 2 and step 3. The largest number is going to be called the absolute maximum values of f. The smallest value of y from step 2 and step 3 is going to be called the absolute minimum values of f. So let's check an example. So the question will always be to find the absolute maximum value and absolute minimum value of the given function at the given interval. So they give us this function f of x equals 2x cubed minus 3x squared minus 12x plus 1 on the interval bracket negative 2 comma 3 and then close bracket. So what do we do? So step 1, we find the critical numbers. How do you find the critical numbers? You take the function that is given, you take its derivative. So the derivative of f of x will give us 6x squared minus 6x minus 12. You set the derivative equals 0 and then you solve for x. So after you set this equals 0 and solve for x, you're going to get x equals 2 and then x equals negative 1. So these are the critical numbers. So step 2 says, then evaluate the function which is given this is the function, and those two critical numbers. So you find f of 2. Okay, you plug this 2 for x into the function, you get f of 2 is negative 19, and then the other critical number is negative 1, so you plug in negative 1 for x into the function, you get f of negative 1 equals 8. Then you go to step 3, you go to the end point of the interval. The end point are this number negative 2 and 3. So you're going to evaluate this function at the end points. Okay, so you find f of negative 2, so you plug this negative 2 for x into this function, the answer is going to be negative 3. And then there's the other end point is 3, so you plug in 3 for x into the function, then you evaluate that to get negative 8. So step 4 says compare all those numbers that we got from step, in this case from step 2 and step 3. So what are the numbers? We got negative 19, 8, and step 3 we got negative 3 and negative 8. So these are the numbers we got. We compare. Among these 4 numbers, the smallest one is negative 19. So then we say there will be so that number negative 19 is the absolute minimum value of the function. And the largest number, the biggest number, is 8. So we say 8 is the absolute maximum value of the function. Okay. So where does it happen? So we know we got the absolute maximum at x equals 2, and we got the absolute minimum at x equals 2, and then we got the absolute maximum at x equals negative 1. Okay, so you write f of negative 1 is 8, and for the minimum value, which is negative 19, you write f of 2 is negative 9. So that's how you find the absolute maximum value and then absolute minimum value. Thank you.